A satellite-based augmentation system, SBAS, is a wide-area differential global navigation satellite system signal augmentation system which uses a number of geostationary satellites, able to cover vast areas, to broadcast primary GNSS data which has been provided with ranging, integrity and correction information by a network of SBAS ground stations. While the primary purpose of SBAS is to provide integrity assurance, use of the system also increases the accuracy and reduces position errors to less than 1 meter. The European Geostationary Navigation Overlay Service, EGNOS, is the European version of this system, and the Wide Area Augmentation System, WAS, is the United States equivalent. SBAS benefits. SBAS provides a more accurate navigation service than basic GNSS range systems and also provides the high level of integrity required for most aviation navigation operations. Several interoperable SBAS have been or are being implemented around the world due to the benefits they provide. SBAS technology provides the opportunity to cover very large areas of airspace and areas formerly underserved by navigation aids. It also adds increased capability, flexibility, and in many cases, more cost-effective navigation options than legacy ground-based navigation aids. SBAS is a key enabler of performance-based navigation, PBN. Approach capability. SBAS enables localizer performance with vertical guidance, LPV, approaches. LPVs are operationally equivalent to a Category I instrument landing system, ILS, but are more economical. LPVs do not require the installation or maintenance of navigation aids at the airport since the navigation service is provided to the aircraft entirely by satellites. Localizer performance, LP, is another type of SBAS-enabled approach procedure that made its debut in January 2011. LPs provide approach capability to runways unsuitable for vertically guided approaches. They provide the lateral accuracy, integrity, and reliability of LPV without the vertical guidance, similar to a localizer-only approach. The European Geostationary Navigation Overlay Service, EGNOS, is a satellite-based augmentation system, SBAS, providing both correction and integrity information about the Global Positioning System, GPS, system, delivering opportunities for Europeans to use the more accurate positioning data for improving existing services or developing a wide range of new services. EGNOS uses a ground-based monitoring network to enable corrections to the Global Positioning System, GPS, signals to be calculated and broadcast by geostationary satellites. This will correct for errors caused by the ionosphere or errors in the broadcast signal itself, enabling higher accuracy and improved integrity monitoring when compared with GPS alone. EGNOS uses 3 geostationary satellites and a network of ground stations to receive, analyze and augment, and then retransmit GPS and eventually Galileo signals. The system is designed to improve accuracy to 1 to 2 meters horizontally and 3 to 5 meters vertically. Integrity and safety are improved by alerting users within 6 seconds if a GPS malfunction occurs, up to 3 hours GPS alone. EGNOS benefits more landings under severe atmospheric conditions, more landings at less well-equipped airports, increased capacity, benefiting both airport and airline operators, curved approaches and more efficient routes, fuel and noise savings, possibility to phase out some expensive ground-based navaids infrastructure and to free valuable radio spectrum that can be exploited for new, other services.
The skies above Europe are becoming increasingly congested, as are Europe's major airports. This growth in air traffic means smaller airports also need to be safely accessible at all times, which cannot be achieved by relying solely on non-precision approaches. However, precision approaches require a substantial investment in ground-based navigational aids. But not anymore. EGNOS, the European Geostationary Navigation Overlay Service, offers enhanced vertical as well as horizontal precision and integrity, improving safety, accessibility, and efficiency for operators, pilots, and airports across Europe. EGNOS is a satellite-based augmentation system that improves GNSS positioning using 3 satellites and a network of more than 39 reference stations in 24 countries, providing much greater accuracy than achieved through GPS alone. Here's how it works. Stations on the ground pick up signals from GPS satellites, which are then centrally processed. The accuracy of the original signals is determined, and factors such as ionospheric disturbances are taken into account. These data are incorporated into EGNOS correction signals and sent to its 3 geostationary satellites. The satellites then relay the signals back to users. The result is substantially improved horizontal and vertical positioning accuracy and data integrity. But how can EGNOS make a difference? EGNOS improves safety by providing pilots with accurate vertical guidance, increasing situational awareness and reducing workload.
Unlike old GPS approaches which gave you only lateral guidance, the new approaches give you both a vertical as well as lateral guidance.
If you can improve the safety of one of the most critical phases of flight, being the approach, you basically improve overall flight safety.
EGNOS can also act as a backup for ground-based systems and is a key element of the future of air traffic management. EGNOS will be pivotal to provide reliable positioning for ADS-B. This is a new cooperative surveillance technology in which an aircraft determines its location using GNSS and periodically broadcasts it, enabling it to be tracked.
EGNOS is a key portion of the ADS-B out technology and is going to allow more accurate transponder technology, more accurate air traffic control management, more accurate point-to-point positioning of aeroplanes for traffic avoidance.
There is, in my mind, no doubt about it that EGNOS is really a major safety enabler in aviation.
EGNOS can be a cost-effective alternative to ILS Cat-1, offering similar performance without the need for costly ground-based infrastructure and maintenance.
The LPV approach allows us to make ILS look-alike approaches with the same minimas, allowing the same service to the passengers, but without the ground-based aids.
With the EGNOS procedure, at a very low cost, we can optimize the operations on the runway.
The lower decision heights enabled by EGNOS can also reduce costly delays, diversions, and cancellations.
We started off with the basic LNAV approach, and that minimum was 500 feet, so that's the lowest a pilot could fly before he had to initiate a missed approach. An LPV using EGNOS brings it down to 250 to 300 feet here, so the aircraft can be a lot lower before it has to initiate a missed approach.
All that's needed is an onboard EGNOS certified receiver, an adapted procedure for the runway end, and an adapted flight management system. For pilots, flying EGNOS approaches only requires limited training and will in many cases be smoother than using an ILS.
Once you practice it and you perform it, it's quite simple. You feel that flight path is smoother and the maneuvers are smoother than flying an ILS.
With an EGNOS procedure, even small and medium-sized airports and heliports remain accessible, even in poor weather conditions.
Today we're being funneled to hubs and major airports. Tomorrow with EGNOS and with LPVs we will be able to fly to all the airfields and aerodromes and regional airports in Europe.
For this kind of runway or airports who do not have an ILS today, you increase the accessibility because of the good performance of EGNOS.
The helicopter receives more precise data, which improves positioning accuracy and reliability. This means we can fly closer to the ground safely.
EGNOS can also reduce the impact of aviation on the environment by facilitating curved approaches and continuous descent paths, and therefore reduce both noise and emissions.
We do continuous descents, so we end up with lower noise print, we end up with less carbon emissions and a better fuel economy.
For helicopters, EGNOS allows custom approach procedures to be developed from any direction using steeper approaches than those flown by fixed-wing aircraft, thereby avoiding densely populated areas. EGNOS was certified for civil aviation in 2011. Hundreds of EGNOS procedures have been published and many more are under development at airports across Europe. The majority of navigation systems in today's aircraft and helicopters now integrate EGNOS.
I don't think we've sold a receiver for the last 7 years that didn't include EGNOS capability.
Furthermore, EGNOS is still improving. EGNOS version 3, which will integrate Galileo, is under development, and EGNOS will be extended across and possibly beyond Europe. EGNOS can provide accessibility, safety, and cost savings in a single proven solution by delivering high precision with low investment.